Imagine booking a flight to the Seychelles, packing your sunscreen, spending thousands of pounds, sitting on that long haul flight for over 10 hours, landing on a tropical island in the middle of the Indian Ocean, and then pulling out your phone to check the weather. Back home in Britain, only to discover that London is hotter than where you just flew to. That is not a joke. That is not a glitch in a weather app. That is the reality that played out on May 23, 2026, when southern England hit temperatures that surpassed Athens in Greece, Split in Croatia, and Victoria in the Seychelles, all at the same time. Three of the most coveted holiday destinations on Earth, all being outgunned by a country that spent decades being the punchline of every sunny weather joke ever written. Britain. Rainy, gray, unpredictable Britain. Hotter than all three of them. At once. Let that sink in for a moment before we go any deeper. Because this is not just a quirky weather stat you scroll past on a Thursday morning. This is a signal. A loud, blazing, 30-degree signal that something fundamental has shifted about the climate of the United Kingdom. And the world needs to start paying attention to what that actually means. The temperatures recorded across southern England over this bank holiday weekend were not just warm. They were historically significant. They were medically alarming in some respects, and they were the product of a chain of atmospheric and climate events that tells a much bigger story than any single temperature reading ever could. So let us break this down properly. Let us talk about what actually happened, why it happened, what the science behind it says, and why this moment matters far beyond a few people sunbathing in Hyde Park with their shirts off. On Friday, May 22nd, 2026, the temperature at Heathrow, Cambridge, and Cranwell in Lincolnshire peaked at 28.4 degrees Celsius. That made it the warmest day of the year in the UK up to that point. But the Met Office was already signaling that the heat was far from finished. Saturday was forecast to push temperatures to 30 degrees Celsius across southern England. And then Monday was being flagged as potentially the hottest May day ever recorded in UK history, with the thermometer anticipated to climb as high as 33 degrees Celsius across southern England and the Midlands. The previous record for a May day in the UK stood at 32.8 degrees Celsius, and that record had been sitting untouched since 1922, over 100 years. And now Britain was on the verge of smashing it during a bank holiday weekend in late May. But here is where the story gets genuinely extraordinary. While Britain was roasting under all of this heat, what was the weather doing in the places that people associate with sun, beaches, and guaranteed warmth? Athens, Greece, one of the most visited cities in Europe and the spiritual home of Mediterranean heat, was sitting at temperatures below what southern England was recording. Split in Croatia, a city famous for its Adriatic coastline and its reliably sunny summers, was also cooler, and Victoria, the capital of the Seychelles, an island nation sitting in the Indian Ocean near the equator, a place where warm weather is not a seasonal luxury but a permanent daily reality, was also being beaten by Britain. Not one of these destinations, not two, all three, simultaneously. This is the kind of weather comparison that makes travel journalists stop mid-sentence and reread their notes twice, because it sounds like something someone made up for a comedic effect. But the Met Office data confirmed it. Southern England was hotter than Athens. Southern England was hotter than Split. Southern England was hotter than Victoria in the Seychelles, three holiday destinations that Brits spend billions of pounds flying to every single year, specifically because of the warmth they offer, all outperformed by the country that invented the phrase typical British weather as a way of apologizing for constant drizzle. Now, to understand why this happened, you need to understand the atmospheric mechanics that were at play. This kind of extreme warmth in Britain does not happen randomly. It requires a very specific setup. What meteorologists were observing leading into this weekend was a powerful high-pressure system sitting over the UK and Western Europe, essentially acting like a giant lid. High-pressure systems suppress cloud formation, encourage sinking air, and create the conditions for heat to build and hold over a region for an extended period. When this combines with warm air being pulled northward from continental Europe, air that has already been baking over the heated landmasses of France, Spain, and Portugal, the temperatures in Britain can spike to levels that feel genuinely foreign to anyone who grew up here. On top of that, the spring of 2026 had already been running unusually warm and dry. Soils across southern England were parched by the time this bank holiday weekend arrived. And dry soil is a heat amplifier. When the ground has no moisture, it cannot use energy from the sun to evaporate water. Instead, all of that solar energy goes directly into heating the air above the surface. This is one of the reasons why a dried-out landscape can produce temperatures that feel dramatically more intense than a wetter environment under the same sunshine. The ground itself was essentially acting as an additional heat source, turning the already warm incoming air into something that felt closer to the Sahara than to Surrey. And then there is the broader climate context, because this event did not happen in isolation. It happened as the latest chapter in an accelerating story about what is happening to Britain's climate. The summer of 2025 was officially confirmed by the Met Office as the UK's warmest summer on record since measurements began in 1884. The mean temperature across June, July, and August of 2025 was 1610 degrees Celsius, 1.51 degrees above the long-term average. That smashed the previous record of 15.76 degrees Celsius that had been set in 2018. And 2025 also went on to become the UK's warmest calendar year ever recorded, with a mean annual temperature of 10.09 degrees Celsius, edging past the previous record of 10.03 degrees Celsius that had been set just 3 years earlier in 2022. Climate scientists at the Met Office ran attribution studies on these numbers. Their findings were stark. A summer as hot or hotter than 2025 is now estimated to be 70 times more likely than it would have been in a pre-industrial climate without human-caused greenhouse gas emissions. In natural conditions, without the influence of human-driven climate change, a summer like 2025 would have had a statistical return period of around 340 years. In the current climate, that kind of summer is now expected to occur roughly once every 5 years. That is not a gradual shift. That is a fundamental reorganization of what the British climate looks like. And that 70 times figure deserves a moment of serious reflection. This is not a fringe estimate from a controversial paper. This is peer-reviewed attribution science from the UK's National Meteorological Service. When scientists say that climate change has made these extreme summers 70 times more likely, they are saying that the world you grew up in, the world where a hot British summer was a rare treat and a conversation starter, is being replaced by a different world. A world where Britain posting 30-degree temperatures in May and outperforming the Seychelles is not a once-in-a-generation anomaly, but a growing feature of the new normal. The 2025 summer also produced 4 separate heatwave events across the UK. A heatwave in Britain is defined as at least 3 consecutive days where temperatures meet or exceed the local heatwave threshold, which ranges from 25 degrees Celsius in the north and west of the country to 28 degrees in parts of England. 2 of those 4 heatwaves in 2025 occurred in June alone. The highest temperature recorded during the entire summer was 35.8 degrees Celsius in Faversham, Kent. That peak was well below the all-time UK record of 40.3 degrees Celsius that was set in Coningsby, Lincolnshire in July 2022. But it was the persistent warmth across the entire summer, rather than any single extreme spike, that pushed 2025 into record territory. Now let us go back to Greece because it deserves its own dedicated chapter in this conversation. Greece is one of the most popular holiday destinations for British tourists, drawing millions of visitors every year who come specifically for its reliably warm and sunny climate. Athens in August can see average highs of 32 degrees Celsius. The Greek islands in summer are synonymous with scorching heat, clear Aegean skies, and warm turquoise water. This is what people are paying for when they book a flight to Corfu, Santorini, or Mykonos. The warmth is the product. It is the entire selling point. And yet on May 23rd, 2026, southern England was warmer than Athens, not marginally warmer in a way that requires a decimal point to notice. Meaningfully, clearly, documentably warmer. The city that gave the world the concept of the Mediterranean climate, a climate so desirable that it is the benchmark against which all other holiday destinations are measured, was being out-heated by London's commuter belt. This is the kind of inversion that makes you stop and genuinely reconsider the mental map you carry around in your head about which parts of the world are supposed to be hot. Croatia is another country that draws enormous numbers of British tourists every summer, and for similar reasons. The Dalmatian coast, of which Split is arguably the crown jewel, offers the kind of warm, sun-drenched Adriatic experience that feels effortlessly glamorous. Split itself is a UNESCO World Heritage City with a stunning Roman palace at its heart, a vibrant waterfront, and the kind of summer temperatures that make it one of Europe's most sought-after warm weather escapes. And on that same May weekend, Britain was hotter. The Seychelles comparison is perhaps the most symbolically powerful of the three, because Greece and Croatia are at least European destinations, still operating within the same general latitude band as Britain, even if they are significantly further south. The Seychelles is an entirely different proposition. It sits approximately 4 degrees south of the equator. It is a tropical nation. It has no winter in the traditional sense. Its temperatures are warm year-round because of its geographic proximity to the equator, not because of seasonal atmospheric conditions. The fact that Britain was posting temperatures that exceeded Victoria and the Seychelles on a May bank holiday is not just a surprising weather statistic. It is a genuinely jarring illustration of how dramatically the parameters of British heat have expanded. For context, the Seychelles attracts British tourists who are specifically seeking escape from the British climate. These are people who want to experience warmth that Britain simply cannot provide. Long-haul flights, significant expense, weeks of anticipation. All of it built around the fundamental assumption that the Indian Ocean offers something that the English Channel does not. And on May 23rd, 2026, that assumption was wrong. It is also worth talking about what these temperatures mean for people who are actually living through them in Britain. Because while the weather comparison with holiday destinations makes for a compelling headline, the reality of extreme heat in a country that has historically been cold is not entirely comfortable. The UK Health Security Agency issued heat health alerts covering large parts of the Midlands, Eastern England, and Southeast England ahead of this bank holiday weekend. These are alerts that the agency normally only issues between June and September. The fact that they were being triggered in late May speaks to how far outside the seasonal norm these temperatures were pushing. Britain is a country whose housing stock, infrastructure, and public health systems were not designed for sustained extreme heat. Homes here were built to retain warmth, not to release it. The majority of residential properties in the UK have no air conditioning. Older buildings in particular can become dangerously warm during a prolonged heat event, particularly at night when temperatures fail to drop sufficiently to allow the fabric of the building to cool down. The Met Office flagged the possibility of what they called tropical nights during some of these heat events in 2025, nights where temperatures remained above 20 degrees Celsius. In a country where people are accustomed to sleeping with windows closed under duvets, a persistent 20-degree night temperature is a significant physiological challenge. The NHS guidance during these periods is consistent. Stay out of the sun during the hottest part of the day, stay hydrated, avoid alcohol and hot drinks, keep living spaces, cool by closing windows during the day and opening them at night when the outside temperature drops. For most of Britain's elderly population, for those with existing cardiovascular or respiratory conditions, and for young children, extreme heat is not just uncomfortable, it is medically dangerous. During the 2022 heatwave, the UK Health Security Agency estimated around 2,985 excess deaths linked to extreme heat. Climate researchers have warned that even at 1.6 degrees Celsius of global warming above pre-industrial levels, the annual number of heat-related deaths in the UK could increase by up to sixfold. And the 2025 summer confirmed that the scale of this public health challenge is already growing. Analysis by the London School of Hygiene and Tropical Medicine and Imperial College London found that climate change intensified Europe's 2025 heatwave, contributing to an estimated 16,500 additional deaths across the continent, including 1,147 deaths in the UK. In London alone, 315 deaths were linked to extreme heat. These are not abstract numbers. These are people who died in part because a country built for cold weather was being asked to cope with Mediterranean-level heat, and not always able to do so safely. The scientific explanation for why Britain is warming so rapidly connects to several overlapping factors. The domination of high-pressure systems over the UK has increased in frequency and intensity. The seas surrounding Britain have warmed significantly, and warmer surrounding seas mean warmer air masses approaching the coastlines. The dry spring conditions that have characterized recent years in the UK reduce the moisture available in the soil, which, as we discussed, amplifies surface heating. And underneath all of these specific mechanisms sits the foundational driver, human-induced climate change, which is systematically raising the baseline temperature from which all weather events begin. The Met Office has been unambiguous about this connection. Climate change does not directly cause individual weather events, but it raises the probability and intensity of extreme heat events dramatically. The 4 heat waves of summer 2025, which might once have passed as pleasant spells of warm weather, were made more prominent by the heightened backdrop that climate change creates. Every degree of additional warming increases the likelihood that Britain will be outperforming the Mediterranean on a bank holiday weekend, and doing so not as a curiosity, but as a routine feature of the calendar. There is also a projection dimension to this that matters enormously. The Met Office has made clear that climate projections show UK summers will continue to become hotter and drier. The events we are describing right now, a Maybank holiday where Britain beats Greece, Croatia, and the Seychelles simultaneously, are not the ceiling of what is coming. They are an early illustration of a trend that is still accelerating. In a pre-industrial climate, a summer like 2025 would have occurred perhaps once every 3 centuries. In the current climate, it is expected every 5 years. And as emissions continue and global temperatures climb further, that return period will shrink even more. Britain in 2040 or 2050 may look back on the temperatures of 2026 the way we currently look back on the temperatures of the 1970s, as a cooler, more manageable baseline that has long since been overtaken. There is one more angle to this story that deserves serious attention, and that is the question of adaptation. Britain has been remarkably slow to build a culture and an infrastructure suited to the heat that is now arriving on its shores. Countries like Greece, Croatia, and Spain have centuries of embedded knowledge about how to live in warm climates. Architectural traditions, daily rhythms, building materials, urban design, all of it evolved over generations in response to Mediterranean heat. Thick stone walls, shuttered windows, shaded courtyards, the afternoon siesta, the culture of eating late in the cool of the evening. These are not just cultural quirks. They are adaptive strategies developed by societies that had no choice but to find ways to function in serious heat. Britain has none of that institutional memory. Its building codes did not mandate heat resilience. Its urban planning did not prioritize shade and airflow. Its public transport lie above 30 degrees. In 2022, when temperatures in the UK hit 40.3 degrees Celsius for the first time in recorded history, railway lines buckled, roads melted, and flights were cancelled from Luton Airport because the runway surface was compromised by the heat. A country that had never imagined needing to worry about its infrastructure melting discovered in a very public and costly way that it was simply not prepared. The gap between the climate that Britain was built for and the climate it is now increasingly experiencing is widening with every passing summer. And closing that gap requires not just individual behavior change, carrying a water bottle, drawing the curtains during the hottest part of the day, but structural investment in housing, infrastructure, urban design, public health capacity, and emergency response systems. That is a generational project that has barely begun. So, when you see a headline saying that Britain was hotter than Greece, Croatia, and the Seychelles on a May bank holiday, it is tempting to read it as a light, amusing weather story, something to share with a raised eyebrow and a laugh. And there is nothing wrong with finding something genuinely striking and even funny about the reversal of expectations it represents. The British relationship with weather is deeply cultural, and moments like these carry a very particular kind of irony that lands hard for anyone who grew up hearing jokes about the British summer. But underneath the headline and the irony and the shared disbelief, there is a story that is far more serious. Britain is warming faster than it was built to handle. Records that stood for over a century are being broken during bank holiday weekends. Heat waves that would once have been seen as once-in-a-generation events are becoming a reliable fixture of the British summer. Public health systems are being stretched by heat-related illness and death in a country that has never had to prioritize that problem before. And the science is unequivocal that without dramatic reductions in global greenhouse gas emissions, all of this will intensify further. The fact that Britain outperformed the Seychelles on a Saturday in May is remarkable. It is genuinely remarkable. But the reason it happened is not. The reason is a warming planet, a shifting climate, and decades of accumulated atmospheric change that are now being felt in the thermometers of Heathrow, Cambridge. Croatia did not get colder. The Seychelles did not get colder. Britain got hotter. And it is going to keep getting hotter. That is the real story behind the headline, and it is one that is only just beginning to be told.